How's it going, guys? Welcome to another episode of Rojo's Reasoning, episode 4. For today's problem, we need to figure out what is the maximum change in wavelength for the Compton scattering of blue light with a wavelength of 480 nanometers. So to do this, we have to first find our equation, and the equation is actually a two-part problem. First, we need to find the change in wavelength, and so that equation is our delta lambda, which is equal to Planck's constant over the mass of the electron times the speed of light, and that is multiplied by 1 minus the cosine of the angle. Now, since we want the maximum, that this cosine of theta has to equal -1. So this whole thing ends up just being delta theta is equal to Planck's constant over the mass of the electron times c. All that is times 2, because this has to be -1, so 1 minus -1 is 2. And we know our constant, so we know Planck's constant, we know the mass, and we know speed of light. So, let's see here, for Planck's constant, we have 6.626 times 10 to the minus 34. And this is kilograms meters squared over seconds, and that is divided by our mass of the electron, which is 9.11 times 10 to the minus 31, and this will be kilograms, which will cancel out with the kilograms up here, and then this is times 3 times 10 to the 8th meters per second, which will end up canceling one of the meters and our seconds. And our final answer will then be in meters. So as I said before, this is all multiplied by 2. So after we calculate this part, which is we end up getting 2.426 times 10 to the minus 12. And as I said before, you end up getting meters. So this is all multiplied by 2, which we got up top here, and our end result for our change in lambda is equal to 4.852 times 10 to the minus 12 meters. And so what we need to do is, for the final equation that we need, it ends up being our change in lambda over our wavelength. And so our wavelength is 480 nanometers, so we need to convert that to meters. So our final equation will end up being 4.852 times 10 to the minus 12 meters, all over 4.8 times 10 to the minus 7 meters, nanometers to meters, and our final answer ends up being 1.011 times 10 to the minus 5. No, sorry, there are no units in that one, because our units end up canceling out. So that is our final answer for the Compton scattering on blue light. Thanks, guys.